Hello guys, today we shall talk about EMNLP 2024 submission Major Entity Identification, a generalizable alternative to coreference resolution. This is Kawshik Manikantan from IIIT Hyderabad, and this work is done in association with Dr. Shubham Toshniwal from NVIDIA and Dr. Makarand Tapaswi and Dr. Vineet Gandhi from IIIT Hyderabad. Imagine you want to study the characters and their occurrences across a novel or a movie. Or say you want to replace the occurrences of certain entities due to legality issues, perform financial analysis specific to certain institutions, and retrieve chunks of data for RAG purposes based on entity-specific cues. All these applications require explicit coreference resolution as a preliminary step and have the following common features. 1. They deal with long documents. 2. They have a predefined set of entities. And 3. They have interest in the occurrences of these specific entities. And 4. They all require tense annotations. So, what are the solutions to track occurrences of specific entities required for the applications discussed? Heuristic prompting is promising but poses challenges including extensive prompt engineering with weak mention detection in coreference resolution, hallucination with larger text, proprietary complications, and the rising costs with larger outputs. Alternatively, we can try supervised coreference resolution models to identify entity clusters. However, filtering these clusters for specific entities can be non-trivial, and these models often struggle to generalize across different domains. In this paper, we propose major entity identification, which is generalizable, tailored for extraction of specific entities, provides explicit mapping, and is faster with parallelization. We shall begin our discussion about major entity identification by defining and understanding coreference resolution. Coreference resolution is this task of finding text spans within a document that refer to the same entity. The CR task aims to detect and cluster all mentions into different entities shown in various colors. Note that CR produces clusters that are unlabeled and need to be explicitly mapped to entities or entity names if we require the mentions of certain entity. This mapping in long documents is shown to be not trivial, and the poor performance of such maps are displayed in future slides. Coming to define major entity identification, it is this alternative referential task where a set of major entities are provided as additional input. And the task is to detect and classify the mentions that refer only to these entities. Note that these representative phrases are succinct and uniquely identify these entities. The presence of these markers transform the clustering formulation of coreference into a classification formulation where we now have specific classes to which mentions are associated with. This removes the need for any additional mappings. In this slide, I would like to introduce our proposed model family, MIRA, which stands for Major Entity Identification via Ranking. We discuss MIRA S or MIRA static first. We start by providing a document to a language model like Longformer, which performs mention detection after encoding. The mention detector identifies potential mentions and generates their representation. We select representation of spans that closely match the input representation phrases like Mustafa and Aladdin. These representations are used to initialize the entity representation. Once we have our entity representations initialized, we process the mentions one by one. We concatenate their representations and pass it through a multi-layer perceptron, F, that scores the association between each mention and the entities. From there on, we select the entity with the highest score. If this score exceeds a defined threshold, we assign the mention to that entity. If not, we classify it as referring to a null set, meaning it doesn't relate to any of the major entities. MIRA S model offers a faster and an effective alternative by keeping the entity representation static. To increase the effectiveness of MIRA S model, we propose an alternative hybrid formulation. In MIRA H, the document is encoded and the mentions are derived. We maintain and score against two entity representations. First, we score the mention with a static entity representation of all entities, and then with the dynamic representation, which is a representation that changes upon mention association. Then the scores are combined and the mention is associated with the entity with the highest score. We then update the dynamic representation of the associated entity with the current mention representation with the help of a weighted mean operator G. Coming to datasets, we evaluate on 3 datasets, the first being lit bank, which annotates CR in 100 literary text, whose average length is around 2000 words. They annotate singletons, that are those entities with a single reference in a given text. The next dataset is fantasy Coref, which annotates CR in 211 fantasy stories with an average length of 1700 words. AFT consists of CR annotations for longer narratives. To benchmark the models for MEI, we adapt the CR datasets discussed before by identifying the top 5 most frequent entities as major entities, and then we derive a representative phrase for each entity cluster using the most commonly occurring name or nominal. Since MEI is a classification task, we use robust and intuitive classification metrics like macro and micro F1. We compare MIRA models against coreference models adapted for MEI. These adaptations utilize cosine similarity and fuzzy string matching methodologies for cluster entity mapping. MIRA S and MIRA H outperform other baselines across benchmarks. In AFT, MIRA H outperforms the best performing baseline by over 11.7% on the macro F1 metric. To evaluate the generalizability of MIRA models, we compare their in-domain and out-of-domain performance. Towards this, we train all models on the OntoNodes dataset and then test their performance on LitBank and Fantasy Coref. The baseline models have a larger performance gap on LitBank due to their differing annotation strategies from OntoNodes. However, the MIRA models recover most of the performance on both datasets, demonstrating robustness to different annotation strategies. We use a few shot prompting methodology to evaluate the performance of LLMs on MEI. We shall now see these prompts and the performance of common LLMs on this task. Firstly, we view the sample prompt used to evaluate the linking or association powers of LLMs. All the mentions in the text are marked, and the LLM is then instructed to annotate the mentions in the given placeholders. We also instruct the model to describe the major entities provided, as this improves performance. Here, we have a look at the example output produced, where the model generates a small description for each entity before producing the required annotations as a part of the same output. For the end-to-end MEI task, we propose a 2-stage prompting strategy where we first instruct the LLM to perform word-level coreference, where every word is classified as referred to a major entity or not. This is then followed by span retrieval. Note that this pipeline is used in lieu of a single-stage prompt that performs mention detection and association simultaneously at span level. Summarizing the LLM performance, we note that while evaluating the linking performance, GPT-4 outperforms MIRA H by around 2%, and CodeLlama is the top performing open source model. In the end-to-end setup, we compare the following versions of models: GPT-4 with an external mention detector, GPT-4 with the prior mentioned 2-stage prompt, GPT-4 single with a single stage prompt, and CodeLlama with the 2-stage prompt. The key results include that GPT-4 with external detection performs best overall, indicating improvement potential in mention detection. There is a significant gap in performance between GPT-4 and open source models, and that GPT-4 with a 2-stage process perform much better than a single stage GPT-4 prompt. So in all, in this work we formally define MEI and present models for the same. It is important to note that MEI is proposed as a generalizable alternative to CR and is not a replacement. We also evaluate the end-to-end referential capabilities of LLMs in a few LLMs that can accommodate a large context windows. Thank you. For more details, you could visit the project page and view the code on GitHub.